Let's look at the correlation matrix and its significance. I'm using the California housing data from the sklearn datasets, load the data into pandas data frame, and when we do df.core, we get the correlation matrix. This is how the correlation matrix looks like. It's hard to interpret the data here, so I'm just loading the data into this seaborne heat map. That's how this one. So we have numbers here. What this numbers means is I've created a correlation matrix scale here. So if the number is between 0.8 to 1, it's a very strong correlation. That means that feature is correlating very high, very strong towards the target variable. And similarly, we have these other values here. This is a general intuition, but this might change based on the field of study you're working on. That is something you have to keep in mind. So let's look at this correlation matrix here. What it does is the first thing we want to look at is our target variable. What features are correlating towards a target variable? So the median income is correlating 0.7, so we can keep this feature. House age is 0.1. It's not a lot, a very weak correlation, but it's worth keeping this one. And similarly, the average rooms as well, 0.2. Although we can delete those columns, run our model, check the accuracy, and then we can decide whether keeping these features or removing these features. If you look at this average bedrooms, the population, the average occupation, and this one, these are all zero. That means they're not correlating anything towards the price. We can confidently delete these features. And one more important thing we should be looking at is the correlation between the features itself. If you see the average rooms here and the average bedrooms, they have a positive correlation of 0.8. This will introduce what is called a multi-collinearity. We don't want the features to be multi-collinear, so we can drop one of these columns, the average rooms or average bedrooms. Again, when we see this to the price correlation, average rooms is contributing towards the price, but not average bedrooms. So we can delete this column here. Similarly, the latitude and longitude as well. So this has a negative correlation because there is a negative here. So we can delete one of these columns. Again, test your model with keeping the columns and deleting the columns, check the accuracy, and then you can decide upon that one. That's how this correlation matrix works. Hope that helps. Thank you.